All right, guys, now we're going to be moving into a section of the code that deals with our various different types of cables and conduit tubing, and they all follow a parallel numbering system, meaning dot 10 in one is the same as dot 10 in the next. So dot 10 is generally uses permitted, dot 12 is uses not permitted, dot 24 is our bending radius, and then dot 30 is our securing and supporting. Most of the questions on the exam have to do with when we can use something, when we can't use it, how often it needs, or how much it can be bent, and then also how often it needs to be secured and supported. So as you're going through, you'll see this numbering system kind of repeating itself as we move through. All right, let's jump into Article 315 to start. 315.1 Scope. This article covers the use, installation, construction specifications, and ampacities for type MV medium voltage conductors, cables, cable joints, and cable terminations. This article includes voltages from 2001 volts to 35,000 volts AC, nominal, and 2001 volts to 2500 volts DC, nominal. And so these cables are suitable for use for voltages from 2001 volts up to 35,000 volts. However, having said that, that's actually not the range of medium voltage. Medium voltage is considered 601 volts to 69,000 volts. So don't confuse medium voltage cables with what medium voltage actually is. Let's move into 315.16. This is marking on those medium voltage cables and conductors. And letter B, we've got method of marking for MV cables and conductors. It says one or more of the methods in 315.16 B1 through B4 shall be used for marking of the cables. And then number one, a surface marking. It says cables shall be durably marked on the surface. The American wire gauge size or circular mill area shall be repeated at intervals not exceeding 24 inches. All other markings shall be repeated at intervals not exceeding 40 inches. So our American wire gauge sizing or our circular mill area needs to be every 24 inches, and then all other markings need to be every 40 inches. And so again, that parallel numbering system that we're talking about, that we're going to follow here through these articles. Dot 10 is going to be when we can use something. Dot 12 is going to be when we can't use something. Dot 24 is how much we can bend it. And then dot 30 is going to be our securing and supporting. So in this section of the code where we start to get into AC cable, FC cable, FCC cable, they all follow that same parallel numbering system. Watch out for that as we're going through here. We're going to pick up starting around page 220. Remember, different editions have different page numbers on here, so this is kind of a guideline. This happens to be the printing that we had in front of us. And so Article 320 is armored cable type AC. And we're going to go down to dot 10. And remember, dot 10 is always uses permitted. Type AC cable shall be permitted as follows. Number 3, in dry locations. So type AC cable we can use in dry locations. Now, dot 12 is always uses not permitted, where I'm not allowed to use it. We're still in Article 320, so we're still talking about AC cable. And it says use is not permitted. It's not permitted in damp or wet locations, or where subject to physical damage. So we need to have that protected, concealed, or protected within a conduit or tube, right? And then also not suitable for damp or wet locations, only suitable for dry locations. Let's go to 320.30. Dot 30, remember, is always going to be our securing and supporting. And so this is securing and supporting of AC cable. Letter B, securing. Unless otherwise permitted, type AC cable shall be secured within 12 inches of every outlet box, junction box, cabinet, or fitting, and at intervals not exceeding 4.5 inches. So not only do we need to secure it within 12 inches of every box, but also every 4.5 feet along the cable. Let's go to 320.40. 320.40 is going to be boxes and fittings for AC cable. The connector or clamp by which the type AC cable is fastened to boxes or cabinets shall be of such design that the insulated bushing or its equivalent will be visible for inspection. Where a change is made from AC cable to other cable or raceway wiring methods, a box fitting or conduit shall be installed at junction points as required by 300.15. So question on the exam says where I'm changing from AC cable to another cable type, what are we going to need to do that in? Some sort of box, fitting, or junction. Let's go to Article 322. Article 322 is flat cable assemblies type FC. And again, we're going to follow that same parallel numbering system. So 322.10, we've got uses permitted. Uses permitted for what? Type FC cable. Number 1 says, as branch circuits to supply suitable tap devices for lighting, small appliances, or small power loads. The rating of the branch circuit shall not exceed 30 amps. So maximum branch circuit rating, if I'm using FC cable, is going to be 30 amps. Let's move on to 322.56 splices and taps. And so these splices and taps are going to be for 322, which is FC cable. And so letter A, we've got splices. Splices shall be made in listed junction boxes. So we need to be able to get to those splices or taps, so we're going to do those in listed junction boxes. And then letter B, taps. Taps shall be made between any phase conductor and grounded conductor or any other phase conductor by means of devices and fittings identified for the use. Tap devices rated not less than 15 amps or more than 300 volts to ground shall be marked in accordance with 322.120C. So if we want to learn about the marking of those, that's going to be in this same article under .120 and the letter C. Let's go to 322.120. We're going to take a look at letter B. This is under construction specifications. So remember, the code is organized into different parts to help us to find our way through the individual articles. And so 322.120, we've got marking, and this is going to be marking on our FC cable. And letter B, identification of the grounded conductor. The grounded conductor shall be identified through its length by means of a distinctive and durable white or gray marking. So it needs to be indicated as white or gray in color to identify that as the grounded conductor. Let's go to Article 324. Article 324 is flat conductor cable type FCC. And we're going to start off here under installation part 2. With 324.10, uses permitted. We're going to skip down to letter C on floors. The use of FCC systems shall be permitted on hard, sound, smooth, continuous floor surfaces made of concrete, ceramic, composition flooring, wood, or similar materials. So it needs to be hard, smooth, and continuous. So a question on the exam says, on concrete floors, we need to have all the following properties if I'm using FCC cable, except 3 of my options are going to be hard, sound, and smooth, or continuous, and then they'll have something else that's not on there. Let's take a look at Article 330. Article 330 is metal-clad cable type MC. And so we're going to start here under Part 2, installation, with 330.24 bending radius. Bends in type MC cable shall be made so that the cable will not be damaged. The radius of the curve of the inner edge of any bend shall not be less than required by 330.24 A through C. We're going to jump down to letter C down below here, skip letter A and B, jump down to C. Shielded conductors. Shielded conductor says 12 times the overall diameter of one of the individual conductors, or 7 times the overall diameter for a multi-conductor cable, whichever is greater. So our minimum bending radius that I can have on there is 12 times for a single conductor, and then 7 times for a multi-conductor cable, whichever is greater. Let's go to 330.30, securing and supporting. So remember, .30 is always going to be our securing and supporting. And so we're going to jump down to letter B, securing. Unless otherwise permitted in this code, cables shall be secured at intervals not exceeding 6 feet. And then down below that, letter C, supporting. Unless otherwise permitted in this code, cables shall be supported at intervals not exceeding 6 feet. So it needs to be secured every 6 feet and supported every 6 feet. Let's go to Article 332, mineral insulated metal sheath cable type MI. And again, dot 10 is going to be our uses permitted. Type MI cable shall be permitted as follows. Number 1, for services, feeders, and branch circuits. Number 2, for power lighting, control, and signal circuits. And so number 3, 4, 5, and 6, those are all areas where you can go ahead and use MI cable, but the ones on the exam are going to be services, feeders, branch circuits, and then power lighting, control, and signal circuits. Let's go to 332.12, uses not permitted. Type MI cable shall not be used under the following conditions or in the following locations. And number 1, in underground runs unless it's protected from physical damage. So I can do it in an underground run if it's protected from physical damage, but if it's not going to be allowed. Let's go to Article 334. This is non-metallic sheath cable type NM and NMC. And we're going to go to 334.10, uses permitted. And it says type NM and NMC cables shall be permitted to be used in the following, except as prohibited in 334.12. Number 1 says 1 and 2 family dwellings and their attached or detached structures and their storage buildings. And then number 2 is for multi-family dwellings and their detached garages are going to be permitted to be of types 3, 4, or 5 construction. So I can use it in 1 and 2 family dwellings and also in multifamily as long as it's type 3, 4, or 5 construction. The IBC will spell out exactly what type 3, 4, and 5 construction are going to be. 334.15, exposed work. So we got our NM cable exposed. And letter B, protection from physical damage. The cable shall be protected from physical damage where necessary by RMC, IMC, EMT, Schedule 80 PVC, type RTRC marked with the suffix -XW or other effective means. The other approved means, sorry. Where passing through a floor, the cable shall be enclosed in RMC, IMC, EMT, Schedule 80 PVC, type RTRC, marked with the suffix -XW or other approved means extending at least 6 inches above the floor. So really, test question is, I've got the conductors that are passing through the floor, the type NM cable, and how high do I need to protect that above that floor, and that is going to be 6 inches. Moving on here, we got 334.30, securing and supporting of type NM cable. So these NM cables are going to need to be supported within 12 inches of the outlet box and then also every 4.5 feet. And so it goes on to say here, it says non-metallic sheath cables shall be supported and secured by staples, cable ties listed and identified for securement and support, straps, hangers, or similar fittings designed and installed so as not to damage the cable at intervals not exceeding 4.5 feet and within 12 inches of every cable entry into enclosures such as outlet boxes, junction boxes, cabinets, or fittings. Let's go ahead and move on to 334.116, the sheath on these NM cables. Type NM, we've got the overall covering shall be flame retardant and moisture resistant. And then letter B, we've got type NMC, the overall covering shall be flame retardant, moisture resistant, fungus resistant, and corrosion resistant. So NM just needs to be flame retardant and moisture resistant. NMC also needs to add fungus resistance and corrosion resistance. Let's move on to Article 338. Article 338 is service entrance cable type SE and USE. And letter A, we've got service entrance. This is under 338.10, uses permitted. We've got letter A, service entrance conductors. Service entrance cables shall be permitted to be used as service entrance conductors. So my SE cable can be used as service entrance conductors. That kind of goes without saying if you know what SE stands for, right? 338.12, use is not permitted. Letter A is specifically talking about service entrance cable. And a type SE cable shall not be used under the following conditions or in the following locations. Number one, where subject to physical damage, and then number two, underground with or without a raceway. So SE cable specifically is not allowed underground. If we want to do underground, we're going to have to use USE cable. Let's move on to Article 340. Article 340 is underground feeder cable type UF. Type UF cable shall be permitted as follows. Number one, for use underground, including direct burial in the earth. And then number three, for wiring in wet, dry, or corrosive conditions. So again, I can use that underground, including direct burial, and then also for wet, dry, or corrosive conditions, type UF cable. Let's go to dot 12, use is not permitted for type UF cable. Type UF cable shall not be used as follows. Number one is service entrance cable. Can't use type UF cable as service entrance cable. And number two, in commercial garages, not allowed. And then also in hoistways, elevators or escalators. In a hoistway, elevator or escalator, that elevator shaft is only allowed to have wiring systems that are associated with the elevator, and type UF cables typically not going to be used on an elevator car. Let's get into our conduit types. Article 344 is our various different conduit types is where we're going to start off here, but we're going to talk specifically in 344 about RMC. So that's rigid metal conduit. 344.28, we've got reaming and threading. It says where conduit is threaded in the field, a standard cutting die with a 1 16 taper or 3/4 inch taper per foot shall be used. So we can't just go rogue and do whatever taper we want. We need to do 3/4 inch per foot. Let's go to Part 3 construction specifications, and we're going to go to 344.30, letter B, supports for RMC. And we've got our trade size over here on the left-hand side, and then we also have our support intervals on the right-hand side. So you can see 1/2 inch just needs to be supported every 10 feet, right? And then things like 3 inches or larger, it's got a larger diameter, it's harder to bend, right? More structural rigidity. That's going to require less often. But specifically on the test, we're going to take a look at a 2 inch, and that needs to be supported every 16 feet. Let's go to Article 348. This is flexible metal conduit, or type FMC. And 348.30, we got securing and supporting of FMC. And letter A, securely fastened. FMC shall be securely fastened in place by approved means within 12 inches of each box, cabinet, conduit body, or other conduit termination, and shall be supported and secured at intervals not to exceed 4.5 feet. So again, within 12 inches of each box, my now FMC needs to be supported, and then every 4.5 feet, right? It's the same thing we saw on NM cable, but obviously a totally different application. 348.60, we've got grounding and bonding of our FMC, and this is letter A for a fixed installation. FMC shall be permitted to be used as an equipment grounding conductor when installed in accordance with 250.118A5. Remember back in Article 250, that was our grounding and bonding rules. It says, let's follow the rules we see in 250.118, where flexibility is not required after the installation. All right, let's go to Article 350, LFMC. One of the questions that we see commonly on the exam is, what does LFMC stand for? And that's liquid type flexible metal conduit. Moving down under there, under uses permitted, dot 10. Notice we're still following that same numbering system through the conduit and tubing, right? 350.10, uses permitted. LFMC, liquid type flexible metal conduit, shall be permitted to be used in exposed or concealed locations as follows. Number one, where conditions of installation, operation, or maintenance require flexibility or protection from machine oils, liquids, vapors, or solids. And then number two, in hazardous classified locations where specifically permitted by Chapter 5. When we get into Chapter 5, these are special occupancies. Some of those special occupancies are hazardous locations, gases in the air, dust in the air, fibers in the air. They're saying we can go ahead and use LFMC in that circumstance as long as it's specifically permitted in that application. So there's a lot of nuance that we'll deal with when we get there. Let's go to Article 353. Now, Article 353 is high-density polyethylene conduit, or type HDPE. And we're going to go down to dot 12, which is, again, was when we cannot use something. 353.12, use is not permitted. HDPE shall not be used under the following conditions. Number one, where exposed. So it has to be concealed. Number two, within a building. And then number four, where subject to ambient temperatures in excess of 122 degrees Fahrenheit, unless listed otherwise. So I can't use it where it's exposed, I can't use it within a building, and I can't use it where I'm exposed to over 122 degrees Fahrenheit. So I couldn't use this in a place like Phoenix or something like that, where it regularly will get over 120 degrees. Let's go to 354.10. Now, if we notice here, 354, we transitioned into a new article here. This is non-metallic underground conduit with conductors, or type NUCC. We're going to go down to dot 10, use is permitted. It says the use of NUCC and fittings shall be permitted in the following. Number one, for direct burial. Number two, encased and embedded in concrete. Number three, in cinder fill. Number four, in underground locations subject to severe corrosive conditions or influences as covered by 300.6. And 300.6, if you remember, that's protection from physical damage. And we're subject to chemicals. Number five, above ground. So we can use this in corrosive conditions. We can use this for direct burial. We can use this above ground where it's encased in not less than 2 inches of concrete. Okay? So a lot of different applications we can use for this non-metallic underground conduit. Let's go to Article 356. Article 356 is LFNC, or liquid type flexible non-metallic conduit. And we're going to go under Part 2 installation to 356.10, uses permitted. LFNC shall be permitted to be used exposed or concealed for the following purposes. Number one, where flexibility is required for installation, operation, or maintenance. Now let's go to 356.120. We should be somewhere around page 247. 356.120, this is marking. LFNC shall be marked at least every 2 feet in accordance with 110.21. So if you want to get some more detail, you can go back to 110.21, take a look at that, but we need to mark that every 2 feet. The type, size, and quantity of conductors used in pre-wired manufactured assemblies shall be identified by means of a printed tag or a label attached to each end of the manufactured assembly and either the carton, coil, or reel. The enclosed conductors shall be marked in accordance with 310.8. So we go into 310 conductors and see the marking on that. That's also how we're going to mark the LFNC conductors. Let's go to Article 358. This is EMT, or electrical metallic tubing. And 358.14, we've got dissimilar metals. Where practicable, dissimilar metals in contact within the system shall be avoided to eliminate the possibility of galvanic action. When we have dissimilar metals, we have this galvanic action that occurs on there, and that's going to end up causing corrosion for us. So we want to stay away from dissimilar metals when we're dealing with EMT. Let's move to 358.30, securing and supporting. Securing and supporting a what? EMT. And letter A, we've got securely fastened. EMT shall be securely fastened in place in accordance with the following. Number 1, at intervals not to exceed 10 feet. And then number 2, within 3 feet of each outlet box, junction box, device box, cabinet, conduit body, or other conduit termination or tubing termination. All right, time to move on to Article 360, which is FMT, or flexible metallic tubing. We're going to go down to 360.12, which is uses not permitted. So we're not allowed to use FMT in these situations. FMT shall not be used as follows. Number 1, in hoistways. Number 2, in storage battery rooms. Number 3, in hazardous classified locations, unless otherwise permitted in other articles in this code. Number 4, underground for direct burial. Number 5, where subject to physical damage. And number 6, in lengths over 6 feet. Let's go to Article 362. Article 362 is ENT, or we call that Smurf tube out in the field, right? So 368.10 is uses permitted. And we're going to go down to number 1. In any building not exceeding 3 floors above grade as follows. We can do that exposed and concealed. Number 2, in any building exceeding 3 floors, as long as it's concealed behind a thermal barrier that has a finish rating of at least 15 minutes. So above 3 floors, in a building that exceeds 3 floors, we can have that concealed, right? But at 3 floors and below, we can have that concealed or exposed, as long as it's not prohibited by dot 12, which is uses not permitted. Let's go to Article 366. Article 366 is auxiliary gutters, and we're going to go to 366.22, number of conductors. And letter A, we've got sheet metal auxiliary gutters. The sum of the cross-sectional areas of all contained conductors and cables at any cross-section of a sheet metal auxiliary gutter shall not exceed 20% of the interior cross-sectional area of the sheet metal auxiliary gutter. So maximum fill that we can have in a sheet metal auxiliary gutter is going to be 20%. Let's move on to Article 368. Article 368 is busways. Busways. And we've got, under Part 2 installation, we've got 368.17. And this is overcurrent protection on our busway. And we're going to specifically talk about where we're not required to have overcurrent protection on a busway. Letter B, reduction in ampacity size of the busway. Overcurrent protection shall be required where the busways are reduced in ampacity. Underneath the exception, it says for industrial establishments only, omission of the overcurrent protection shall be permitted at points where the busways are reduced in ampacity, provided that the length of the busway having the smaller ampacity does not exceed 50 feet and has an ampacity at least equal to 1/3 the rating of setting the overcurrent device next back on the line, and provided that such busway is free from contact with combustible material. So as long as I'm not exceeding 50 feet from that, I'm at least 1/3 of the ampacity of the overcurrent device next back on the line, and I'm in an industrial establishment that's free from contact with materials, combustible material, then I can omit the overcurrent protection on the reduced ampacity busway. It's a lot of nuance going on there, but they're going to have to mention all that stuff in the test question. Still under busways, we've got 368.30 support, so this is going to be our support of our busways. It says, busways shall be securely supported in intervals not exceeding 5 feet unless otherwise designed and marked. So every 5 feet we need to support our busways. Let's go to Article 372. Article 372 is cellular concrete floor raceways. And we're going to jump under Part 2 installation to 372.20, size of the conductors. No conductor larger than 1/0 shall be installed except by special permission. And so typically if I need that type of special permission, I probably want to get written permission so I got documentation and backup in case something goes wrong down the line, right? 378.56, we've got splices and taps. Splices and taps shall be made only in header access units or junction boxes. So if I've got a splice or a tap for a cellular concrete floor raceway, I need to do that in a header access unit or in a junction box. Let's jump to Article 374, which is cellular metal floor raceways. And we're going to go under Part 2 installation and 374.22 maximum number of conductors in a raceway. The combined cross-sectional area of all conductors or cables shall not exceed 40% of the interior cross-sectional area of the cell or header. So our maximum fill on that is going to be 40%. Let's jump to 374.56, which is going to be our splices and taps. Splices and taps shall be made only in header access units or junction boxes. For the purposes of this section, the so-called loop wiring shall not be considered to be a splice or tap. So those splices or taps need to be made only in header access units or in junction boxes. Let's go to Article 376, metal wireways. And 376.22, we've got number of conductors and ampacity. And letter A, cross-sectional areas of wireway. The sum of the cross-sectional areas of all contained conductors and cables at any cross-section of a wireway shall not exceed 20% of the interior cross-sectional area of the wireway. So again, maximum fill in a metal wireway is going to be 20%. Let's move on to non-metallic wireways. So 378.22, this is our number of conductors in a non-metallic wireway. The sum of the cross-sectional areas of all contained conductors or cables at any cross-section of the non-metallic wireway shall not exceed 20% of the interior cross-sectional area of the non-metallic wireway. So again, maximum fill on these non-metallic wireways is going to be 20%. Okay, non-metallic wireways different than a metallic wireway. Typically, we see a non-metallic wireway as a lot of times you'll get like a baseboard, right? That's actually non-metallic that has a hollow cavity back behind it. That would be an example of a non-metallic wireway, and we're running our wires in those baseboard cavities. 378.30, we got securing and supporting for non-metallic wireways. They need to be supported every 3 feet horizontally, right? And then also at every end and joint. And in no case shall that distance between the supports be more than 10 feet. Let's go to Article 386, surface metal raceways. Surface metal raceways are nice because I can access everything real nice, but let's be honest, they're kind of ugly, right? Let's go to 386.10, uses permitted. Number 1, in dry locations. So I can use surface metal raceways in dry locations. I can also use them in Class 1, Division 2 hazardous locations. So Class 1 hazardous location has gases or fumes. Division 2 means I don't normally have a hazard, but if something went wrong, now I've got a hazard, okay? So under normal operating conditions, I do not have gases or vapors, but I could have a spill or something like that that could cause us to have gases or vapors in the air. Number 4, extension through walls and floors. Surface metal raceway shall be permitted to pass transversely across, right, through walls, dry partitions, dry floors, if the length of the passing through is unbroken. Access to the conductors shall be maintained on both sides of the wall, partition, or floor. So I still need to be able to get to everything for servicing purposes, but they'll allow me to pass that through a dry wall as long as I can get to both sides. All right, let's go to 386.22, number of conductors or cables, and this is going to be in a surface metal raceway. The number of conductors or cables installed in surface metal raceways shall not be greater than the number for which the raceway is designed. Great. Don't do any more than you should. That's what it says, right? Cable shall be permitted to be installed where such use is not prohibited by the respective cable articles. So if it says back in Article 320, AC cable, if it says back there you can't use it in a surface metal raceway, then you can't use it, right? Article 386 is still surface metal raceways, but now we're talking about splices and taps in surface metal raceways. And so splices and taps are going to be permitted in surface metal raceways as long as we've got a removable cover in which we can access that. Now, if we don't have removable covers on there, then they're going to only allow me to do those in boxes. Now, at that splice and tap, instead of the fill that we learned earlier, the number for which the raceway is designed, they'll allow me up to 75% fill of its area at that point of the splice or tap. But again, it needs to be made in a box, or that splice and tap needs to be made on a surface metal raceway that has a removable cover so I can get to it. It needs to be accessible. That's what the code would call that. All right, let's go to Article 388. This is surface non-metallic raceways. And 386.56, splices and taps. Same rules we had with the surface metal raceways, right? Surface non-metallic raceways, I gotta be able to get to it, right? And maximum fill is 75%. It says splices and taps shall be permitted in surface non-metallic raceways having a cover capable of being opened in place that's accessible after the installation. The conductors, including splices and taps, shall not fill the raceway to more than 75% of its area at that point. Let's go to Article 390. Article 390 is underfloor raceways. And we're going to start off here at 390.12, uses not permitted. And it says, underfloor raceways shall not be installed, number one, where subject to corrosive vapors, and number two, in any hazardous classified location. So no corrosive vapors, and then also no flammable vapors or dust in the air, or combustible dust, right? We all have dust in the air, but this is combustible levels of dust. And then also fibers that are flying in the air. Let's go to Article 392. Article 392 is going to be our cable trays. And we're going to take a look at 392.10, uses permitted for cable trays. And we're going to look specifically at letter B in industrial establishments. And number one says single conductor cables and single insulated conductor cables. It says letter A, single conductor cables and single insulated conductors shall be 1/0 or larger and shall be of a type listed and marked on the surface for use in cable trays. Let's go to 392.18, cable tray installation, and letter A of a complete system. We're going to skip down to the second sentence, third sentence in there. It says the cable tray system shall be permitted to have mechanically discontinuous segments between cable tray runs or between cable tray runs and equipment. So it doesn't have to be mechanically continuous. It says we can have mechanically discontinuous segments. Let's go to 392.22, number of conductors and cables. And this is letter A, number of multi-conductor cables rated 2,000 volts or less in cable trays. And we're going to go down to number 1. And really, we're going to skip letter A. We're going to jump down to letter B. It says, where all the cables are smaller than 4/0, the sum of the cross-sectional areas of all the cables shall not exceed the maximum allowable cable fill in column 1 of 392.22A1 for the appropriate cable tray width. Okay, so it's going to refer us to a table here. And what we need to do is we need to know under letter B that all of my cables are going to be smaller than 4/0. So let's go ahead and turn to that table. It should be around page 270 here. And this is 392.22A1. This is allowable fill. So this is going to tell us how much we can fill that cable tray. Now, all of my conductors are smaller than 4/0. That puts me into column number 1, applicable to 392.22A1B. I hate that, right? Why didn't they just put in column 1, all of my cables are smaller than 4/0, right? That had made that much clearer. And so they're on the test, they're going to ask us about a 9-inch cable tray, and they're going to ask about the maximum amount of fill that we can have in there, and that's going to be 10.5 square inches. Let's move on to Article 410. So Article 410, what we're doing is we're getting into Chapter 4. Okay, so Chapter 4 is equipment for general use. This is very common equipment that we see commonly across all electrical installations or most electrical installations. We're going to see things like lights, right? And so luminaires, lamp holders, and lamps is what Article 410 is. We're going to start off here around page 312 with Part 2, luminaire locations. And these are luminaires specifically not in any closet, but in a closed closet. And letter C, luminaire types not permitted. It says incandescent luminaire with open or partially enclosed lamps and pennant luminaires or lamp holders shall not be permitted. So in a closed closet, I'm not allowed to have a bare light bulb with a chain on it, right? I need to have something that's got an enclosure on it. Let's go to 410.30 supports. What are we supporting? Luminaires, right? And letter A, luminaires and lamp holders shall be securely supported. A luminaire that weighs more than 6 pounds or exceeds 16 inches in any dimension shall not be supported by the screw shell of a lamp holder. Right? So I can't have where I screw the light bulb in. They call that a screw shell lamp holder, right? We call that an Edison base. They're saying that luminaire that weighs more than 6 pounds can't be just supported by that Edison base. And letter B, metal or non-metallic poles supporting luminaires. Number 1 says a pole shall have a handhole not less than 2 inches by 4 inches with a cover suitable for use in wet locations to provide access to the supply terminations within the pole or pole base. Again, minimum size they're going to ask you about, that's 2 inches by 4 inches. 410.44, round about page 314, we've got 410.44, connection to the equipment grounding conductor. Luminaires and equipment that require connection to an equipment grounding conductor in accordance with 410.42 shall be mechanically connected to an equipment grounding conductor. So we need to connect that mechanically to an equipment grounding conductor. 410.54, we've got pennant conductors for incandescent filament lamps. And we'll find that this falls under Part 6, wiring of luminaires. Remember, again, the code is organized into these parts. And so it helps us define stuff. So there's going to be like electric discharge luminaires in one part, right? There's going to be flush mounted and recessed luminaires in another part. So helps us to break down Article 410 into smaller chunks. 410.54, we got pennant conductors for incandescent filament lamps. And letter B, size. Unless part of a decorative lighting assembly, pennant conductors shall not be smaller than 14 gauge for mogul base or medium base screw shell lamp holders, or smaller than 18 gauge for intermediate or candelabra based lamp holders. So 14 gauge for mogul base or medium base, right? And then 18 gauge for intermediate or candelabra based lamp holders. Let's go to 410.62, cord connected lamp holders and luminaires. We're going to skip letter A and letter B. We're going to jump down to letter C, electric discharge and LED luminaires. And number 2, provided with a mogul base screw shell lamp holder. Electric discharge luminaires provided with a mogul base screw shell lamp holder shall be permitted to be connected to branch circuits of 50 amps or less by cords complying with 240.5. Receptacles and attachment plugs shall be permitted to be of a lower ampere rating than the branch circuit, but not less than 125% of the luminaire full load current. So I can have a receptacle on that mogul base screw shell lamp holder, that's perfectly fine, but it needs to be at least 125% of that luminaire full load current. 410.71, we've got disconnecting means for fluorescent or LED luminaires that utilize double-ended lamps. We're going to skip about halfway into there and highlight 4 existing installed luminaires without disconnecting means. At the time a ballast or LED driver is added or replaced, a disconnecting means shall be installed. So if I've got an existing installed luminaire without disconnecting means and I'm adding a ballast or LED driver, now I have to install a disconnecting means. When do we need to do that? Only on those double-ended lamps. 410.80, we've got luminaire rating, and this falls under Part 7, which is construction of the luminaires. And letter A, marking. All luminaires shall be marked with the maximum lamp wattage or electrical rating, manufacturer's name, trademark, or other suitable means of identification. So again, that's a list of stuff. All the following needs to be marked except, right? And so we have 3 items from this list and a 4th item that does not appear on here. Let's go to 410.100. This is bases for incandescent lamps. An incandescent lamp for general use on lighting branch circuits shall not be equipped with a medium base if it's rated over 300 watts, or with a mogul base if it's rated over 1500 watts. Special bases or other devices shall be used over 1500 watts. So if I'm over 300 watts, I could use a mogul base, but if I exceed 1500 watts, now I'm going to be required to have some sort of special base for it. Let's go to Part 10, which is special provisions for flush and recessed luminaires. You see how it's organized in those parts? If I'm looking for flush or recessed luminaires, right into Part 10, right? Makes most of that article go away, and we're dealing with just that one part. 410.116, clearance and installation, and this is clearance from combustibles for a non-type IC recessed luminaire. So that's one that's not identified for contact with insulation. And so it says a recessed luminaire that's not identified for contact with insulation shall have all the recessed parts spaced not less than a ½ inch from combustibles. The points of support and the trim finishing off the openings of the ceiling, wall, or other finished surface shall be permitted to be in contact with combustibles. So a question on the exam is going to ask about that clearance to combustible for a non-type IC recessed luminaire, and it says a ½ inch right in there. Let's move to 410.137, and you'll notice we'll transition into Part 12, which is special provisions for electric discharge lighting systems of 1,000 volts or less. 410.137 is equipment not integral with the luminaire. It says in letter A, metal cabinets. Auxiliary equipment, including reactors, capacitors, resistors, and similar equipment, where not installed as part of luminaire assembly, shall be enclosed in an accessible, permanently installed metal cabinets. So it needs to be accessible and permanently installed in a metal cabinet. Let's go to Article 411. Article 411 specifically low voltage lighting. We're going to take a look at the voltage limitations on here to indicate exactly what are we talking about when we're talking about low voltage lighting. And it says, the operating voltage of low voltage lighting systems and their associated components shall not exceed 30 volts AC or 60 volts DC. Now, if wet contact is likely to occur, the operating voltage of low voltage lighting systems and their associated components shall not exceed 15 volts AC or 30 volts DC. So in a dry location, 30 volts AC. In a wet location, 15 volts AC. Let's go to 411.4, low voltage lighting systems. We're going to jump down to that second sentence in that paragraph. It says, the output circuits of the power supply shall be rated for 25 amps maximum under all load conditions. And 411.8, we've got branch circuit. Lighting systems covered by this article shall be supplied by a 20 amp maximum branch circuit. Let's go to Article 424. Article 424 is fixed electric space heating equipment. Still in Chapter 4, general equipment. I'd agree this is fairly common equipment, right? Chapter 6 is when we're actually going to get into specialized equipment, things like solar, swimming pools, things like that, right? Stuff that's not in every circumstance. That solar is becoming more and more common, but it's not in every application, right? Fixed electric space heating equipment, again, not every application, but it's fairly common. We're going to go to 424.4 branch circuits for this fixed electric space heating equipment. We're going to jump down to letter A, branch circuit requirements. And it says branch circuits supplying 2 or more outlets for fixed electric space heating equipment shall be rated not over 30 amps. And then letter B down below there, branch circuit conductor sizing. The branch circuit conductor ampacity shall not be less than 125% of the load of the fixed electric space heating equipment and any associated motor or motors. So they're going to be looking for on the exam that percentage, and that's going to be 125. Under letter A, they're going to be looking for a number, and that's going to be 30 amps. 424.11, we got supply conductors for fixed electric space heating equipment. Fixed electric space heating equipment requiring supply conductors with an insulation rating over 60 degrees Celsius shall be clearly and permanently marked. This marking shall be plainly visible after installation and shall be permitted to be adjacent to the field connection box. So it doesn't have to be in the field connection box, it can be adjacent to, but it needs to be a minimum temperature rating of, actually it doesn't say 60 degrees minimum, it says greater than 60 degrees. Real important there, right? So is 60 degrees allowed? No. It needs to be greater than 60 degrees. I would have liked it better if they said 75 degrees or higher, right? But they said greater than 60 degrees. That's a little confusing, so pay attention to the nuance there, right? Details make all the difference and can make the difference between you getting that correct on the exam and getting that one wrong on the exam. And that may make the difference between you passing and failing on there. So we got time to slow down and read this stuff. Let's go to 424.22. This is overcurrent protection. You'll notice we're in a part that's part 3, control and protection of fixed electric space heating equipment. And letter B, resistance elements. Resistance type heating elements in electric space heating equipment shall be protected at not more than 60 amps. So maximum overcurrent protection we can have on these resistance type heating elements for fixed electric space heating is going to be 60 amps. Let's go to 424.41, ceiling installation of heating cables, and you'll see that's in part 5, which is electric space heating cables, so it makes sense that it's where it's at. On dry board, in plaster, and on concrete. And we're going to skip all the way down to letter F, secured. That may take us on to another page depending on the printing of your book. So we're going to skip A, B, C, D, and E. We're going to go down to letter F, secured. Cables shall be secured by means of approved stapling, tape, plaster, non-metallic spreaders, or other approved means at intervals not exceeding 16 inches, or at intervals not exceeding 6 feet for cables identified for such use. So they're just going to ask us, in general, how often does that need to be secured or supported? Every 16 inches, right? They'd have to tell us that these were identified for greater intervals if they wanted us to grab that 6 foot. Let's go to Article 426. Article 426 is fixed outdoor electric de-icing and snow melting equipment. Now, this one I kind of disagree with being in Chapter 4. I really feel like this should be in Chapter 6, okay? But, you know, that's me. I'm not the one who's writing the code. By the way, in 2029, they're going to radically reorganize the code, and so maybe they'll change things like that. 426.20, we've got embedding, de-icing, and snow melting equipment. And letter A, watt density. Panels or units shall not exceed 120 watts per square foot of heated area, right? So maximum watt density is 120 watts per square foot for resistance heating elements for electric de-icing and snow melting equipment. Let's go under Part 6, Control and Protection. And 426.51, we've got controllers. And this is a temperature controller with an off position. Temperature-controlled switching devices that indicate an off position and that interrupt line current shall open all ungrounded conductors when this control device is in the off position. These devices shall not be permitted to serve as the disconnecting means unless they're being capable of being locked in the open position. So it can't serve as a disconnecting means unless you can lock it in the open position. Let's go to Article 427. Article 427 is fixed electric heating equipment for pipelines and vessels. We're going to jump right into Part 7, Control and Protection, and we're going to go 427.56 Controls, and then Temperature Control with an off position. We're going to find that this is the same rule we learned before. These devices shall not be permitted to serve as a disconnecting means unless being capable of locked in the open position.